I've created a kind of a tabletop discussion for us today, going through this OWASP top 10 security document for large language model applications. Again, OWASP being the Open Worldwide Application Security Project, we know that they create great content that we all depend upon. And they created a great document here detailing 10 of what they feel are the most important things to look to when it comes to large language models. I wanted to take the earlier videos that we did to discuss at a deeper level some of the concepts that I had discussed previously in regards to the differences between some of the more well-known vulnerabilities having to do with regular applications to some of the potentially unknown vulnerabilities and or challenges with AI systems. I've created a kind of a tabletop discussion for us today, going through this OWASP top 10 security document for large language model applications. Again, OWASP being the Open Worldwide Application Security Project, we know that they create great content that we all depend upon. And they created a great document here detailing 10 of what they feel are the most important things to look to when it comes to large language models. I'm going to use this document to help differentiate between what I call these more common vulnerabilities and threats versus the kind of unknown black box large language model challenges that are out there. Although we do need to be concerned about the, quote, common vulnerabilities and threats to an AI system, cross-site scripting, cross-site request forgery, server-side request forgery, things like that, input validation challenges, all of these things, and they are critical. To be clear, I'm in no way saying that we should not be looking to these same security tenets that we do for all other applications that are out there. What I am saying is we do need to look at that, and we need to look at the different use cases and threat scenarios that can arise from these large language models that we may not, as a community, be as sure about, and we may not have as much information yet on. And these are some of the areas of this top 10 that I want to discuss with you today, and I'm really interested in your feedback, and I hope that we can start a discussion today about some of these scenarios, whether or not they're realistic, if they are maybe not realistic enough, and what can be done as a community to come together to create a tool set or a methodology or even a plan that can allow us to have a way forward to address these large language model and other AI security control concerns. It seems evident that there will be more reliance on AI systems as time goes by. So how do we ensure that the core functionality, the core systems of these AI constructs continue to operate the way that they're intended, and that there isn't any manipulation or there isn't any unintended functionality added to these AI systems over time, so that we can not only trust these systems, but we know that we can in fact control them to a high degree. This obviously starts with things from allowing AI to be used in ways that we haven't yet thought of, even from a data scientist perspective, to those ways that we can actually think about. And I know that some of this is science fiction, worrying about AI becoming out of control or utilizing its power to take over certain systems or to affect critical systems that we have in a way that we don't intend. But for some of us who've been in this industry, as long as I've been in it, the late 90s, early 2000s, all this AI technology that we're seeing today is like science fiction, at least to me. And I think that we do have to think out of the box. We do have to start thinking about different scenarios and use cases that push our understanding of how technology can be used when it comes to this type of neural deep learning large language model computational power. So in the end of the day, I'm hoping that this discussion helps us to think about AI in a different aspect. As much as we do want to look at these more common threats, again, as I discussed earlier, I want to think about some of the very specific threats that AI and these large language model constructs can create. So looking at this top 10 list, I want to focus on a few of them, again, from this perspective outside of the regular threats that we see for other applications. The large language model 1 prompt injection, only a specific aspect of that. Number 3, 5, and 7, which seem to tie together for what I want to discuss, which is the training data poisoning, supply chain vulnerabilities, and insecure plugin design. And really, this is to lead us into the main discussion, which is the large language model 8, excessive agency, and then 9, over-reliance. And I want to try to tie them all together with this concept. So starting with large language model 1 prompt injection, this manipulates a large language model through what they call crafty inputs, causing unintended actions by the LLM. The overwriting of the actual system prompts is something we know from other applications. That's not really what I want to discuss. It's more about what does it mean when they say unintended actions by the large language model. So to give an example of this, it's literally their last or one of their last examples, which they call an advanced attack. They talk about the fact that the large language model, when it's compromised, can actually be utilized by the attacker. So unlike when I'm an attacker and I've taken over a system, and I have access, and I can do things based on that access. The difference here is I actually have now this AI construct as my ally, and it says specifically that the LLM can actually assist the attack, surpassing standard safeguards and keeping the owner of the systems themselves unaware of the intrusion. So effectively, the large language model is acting as an agent for the attacker. And some people could say, well, we can kind of do that with regular applications to some degree, but this is actually another intelligence that is allowing the attacker not only to go past safeguards or to bypass them, but allowing the attacker to have assistance from this LLM to do, again, I don't know what level of things that this system can do, but that's the point of this discussion is, what does it mean when you actually bypass the system or use the resources of the large language model to your assistance to allow you to do more things, to allow you to have more access, to bypass safeguards, to even maybe think of scenarios to exploit more than you even had in the first place. So this is kind of the flavor of what I want to discuss when it comes to these OWASP top 10 vulnerabilities and threats. How is it on a higher level that these AI constructs can be utilized by an attacker to do things outside of the regular exploits that we see with application bypasses or any kind of exploits that we see in regular hacking today? Just to kind of prove this point, they talk about some of the mitigation strategies, which I find interesting. So, for example, add a human in the loop for extended functionality. So right away, what that tells me, and I'm not trying to put this down, what's been suggested here by OWASP, they're very, very smart people, but what it tells me is they know that this is an issue, and now there's an actual outside of the AI fix, for lack of a better word, which is a human being, to make sure that there's some kind of watchdog function for this AI system. And specifically, they talk about when performing privileged operations, right? So such as sending or deleting emails. So I think we all know that these kind of constructs, anything with the cloud, anything to do with AI, is very automated. And if you start adding these manual injections in between processes, I don't know how tenable that would be as a true solution going forward. And to that point, number 5, they talk about manually monitoring the actual large language model input and output periodically, it says, to check that it is actually operating as expected. Again, I'm not saying it can't be done. I'm not saying it's not a good idea. What I'm saying is, from an overall management for these systems, I don't know if that is a truly tenable and reasonable solution for something as advanced as these large language model AI constructs. So this is, again, starting to show me right away when I read this document, I started to say, okay, they know this is a challenge. From a data scientist perspective, maybe how they can inject some logic and or boundaries and or sandboxing that can ensure these kind of controls are put in place, but within the AI system. So I'm sure that is probably something they're working on, but that's how I could see these mitigation strategies being more effective, is if it's actually a part of the AI construct itself, like a self-check programming, for lack of a better word. Then again, of course, then how do you trust that programming if it's all part of the same AI model itself? So the next 3 are tied together for me. So I'm looking at the 03, training data poisoning, 05, supply chain vulnerabilities, and then 7, which is the insecure plugin design. And they kind of work hand in hand from my perspective, which is what the large language model utilizes for its information. So the training data itself, which is incredibly important, the supply chain that the large language model utilizes, other data sets, other pre-trained models, other plugins, and the vulnerabilities that introduces, and then an actual insecure plugin design, which is similar again to the training data poisoning in the way that it's bad data. So how do all of these work together? What effect does this have on the actual AI large language model? And what can it do, or what will happen to that model if these different areas are affected? We do care about all these regular exploits and their effects on data theft, compromise, and manipulation, that's for sure. What I do want to, again, pivot towards is more what happens with the AI construct itself, and what happens if it's manipulated, changed, commandeered. What are some of the threats that come from this different level of exploit? So starting with large language model 3 from the OWASP top 10, this occurs when the large language model training data is tampered with. Introducing, it says here, vulnerabilities, but also biases that compromise security effectiveness and or ethical behavior. So it's kind of along those lines, the ethical behavior component. What does that mean? Again, going back to that data scientist example, that maybe isn't the friendliest individual and is unhappy in life, and decides that either as a direct data scientist for the large language model or on his own trying to get that bad set of data into this large language model, trains this construct to think differently and to think along the lines that this data scientist wants it to. So to think of ways of advantage and exploit of key critical systems within our infrastructure, and to take it over and or to just do bad things. Like, what does that mean? So one of the key attack scenarios that they use, and this is what I'm talking about, is that the LLM, generative AI prompt, can mislead the actual users based on this poisoned data set. So it can create biased opinions and even worse things than that. It can create outputs that we don't want to see, things like hate crimes that even lists here within the OWASP document. So this is my point, is that these large language models are as good as the data that they contain. And by poisoning this data source can create these unintended outputs. And the more we become reliant on these AI systems, how do you continue to be confident in what these AI constructs are producing? In other words, what information they're sharing with you. We're very impressed by how quickly they can quickly come up with answers and essays and responses to really any question that we have. But my concern will be, how do we ensure that we keep that level of consistency and accuracy over time? And one of the mitigation strategies they have is what I talked about earlier as well, which is this sufficient sandboxing, through, they say, network controls to prevent the model from, it says, scraping unintended data sources and or injected data sources, I would assume in this cases too. And this could also be a part of the release code management process where the data scientists are working together in this iterative way where they are not allowing certain people to inject this bad data source, and that there's some kind of checks and validation throughout the process. Again, this idea of security shifting left with applications and cloud and everything else, I definitely believe with the development of AI that we need to approach its creation and construct through the shifting left methodology. We want to make sure that we're thinking about security as early as possible in the development of these AI systems. We now jump to 5, which is the supply chain vulnerabilities, which is, again, from what I'm concerned with and what I'm talking about today, the same kind of challenges. So we have things like this idea that through the supply chain, the large language model will pick up vulnerabilities and it'll impact the integrity of the system and of its training data specifically. So for machine learning models, for any kind of deployment platform in general. So same output, which is why I've linked them together, these vulnerabilities can lead to biased outcomes, to security breaches in general, and even complete system failures. So how do we control this? How do we control these different supply chain mechanisms and data that the large language model depends upon to ensure that it's a clean source and that it is maintained and updated in a way that is only what is expected, and that there aren't any foreign data injections of any type that are not intended, to ensure that, again, overall, that the AI model construct is functioning and continues to function the way that we intend it to in the first place, how it was designed to be functioning. So again, a lot of manual discussion here when it comes to mitigation strategy. So things like carefully vetting the data sources and the suppliers, all for sure. Third-party risk management on this is going to be big in regards to any kind of outside sources of information and data. No question about it. How is this going to be automated? How is this going to be, especially with something with so much data, how are you going to be able to ensure that you have covered every single data set, every single type of data that is being utilized by this large language model? It sounds to me, again, as a very big endeavor to try to ensure complete accuracy over. So something to consider. Again, then they talk about this is also very specific to really other application security challenges. It's making sure that the sources are reputable and that this isn't just some person out there on GitHub that you don't know and you're getting data sets or data sources from untrusted sources. How do you maintain that? How do you manage that over time? How do you create an upkeep that is a viable automated solution over time? So some of the attacks that are here, many of these attacks are, again, what I call more the common exploits. One of the attack scenarios that jumps out to me having to do with what we're discussing today is an attacker poisoning a publicly available data set to help create a backdoor when fine-tuning the models themselves. So this backdoor subtly favors certain companies in different markets. Now, again, this is from a list of more critical threats, and don't get me wrong, again, having any kind of bias is bad. If I, somehow taint the AI for allowing some people I know to get loans or to get mortgages, it's obviously unethical and bad. This is starting to create new questions in my mind when it comes to what if the information is much more critical, right? When we talk about even military scenarios, when it comes to making decisions that do affect life and death. Maybe it's a medical AI program. I don't even like to think about things like that, but getting it wrong information when someone's life is at stake is obviously at a much higher level of criticality. But these types of attack scenarios open up those different possibilities. And I think as a community, we have to take them extremely seriously and work together to figure out ways to help contain these models and to ensure that this kind of scenario doesn't find the light of day. So finally, we have the large learning model 7, OWASP exploit here, which is this insecure plugin design or list from their top 10. A plugin could potentially treat the large language model content as being created entirely by the actual person that's supposed to be creating it, and it allows any requested action without requiring any further authorization. So here's another aspect. The capability of someone who helps to design this large language model to fully utilize it, take it over, and perform whatever functions that person wants. So again, this is insecure plugin design. This could be simply something created by somebody as a part of the overall construct, perhaps again, and hopefully unknown to everybody else. And this is where this whole development lifecycle component comes in. How do we make sure through release code management and the promotion of, I use code again, but I know it's more than that, along these iterative stages, how do we make sure we're controlling that so that these things cannot be injected in there and allow these kinds of, for again, lack of a better word, backdoor access for these bad actors to come in and take extra control or additional control that they don't have the authorization to do things that we're not even aware of, things above and beyond the construct's intended purpose. So when you combine all these three together, the third, fifth, and seventh of the top 10 OWASP list for the large language models, there's some powerful options for these attackers. And again, it comes down to what can we do to mitigate this? What can we do from a control perspective outside of our regular, controls that maybe we use for other application security challenges that are out there today and that we're more familiar with? For the prevention and mitigation strategies that they have here, really this is a summary for all three of them, in my opinion. The enforcement of strict parameterized input. Like that is one aspect right there. Making sure that we, as best as possible, almost like a firewall strategy, we have everything as an implicit denial and then we allow certain inputs, but we don't go from the allow everything perspective and then try to minimize. I think we try to actually start with not allowing it to do anything and then only giving particular functionality as required. Again, I'm not a data scientist, but at the same time, from a security perspective, it seems to make the most sense to limit functionality and to design from a limitation perspective versus a complete openness perspective. So things like input validation, we talked about this, and overall sanitization of every aspect when it comes to the plugins themselves or the data sets, making sure that they're inspected, and here's a key thing, tested. So there's going to need to be a ton of QA on these systems, and you're going to need people like us to come in to think like a bad guy, to think like somebody who is looking to exploit these systems, that is going to try to find creative ways to utilize the system that are not a part of the original design feature set. So, I've always looked at it this way too, that hackers from my generation, they're always looked at as a bad thing, maybe today, but the truth is they're actually just very intelligent people that have looked at a problem set and tried to find new and innovative ways to exploit and or manage those problems. And you need that kind of thinking with something as complicated and as complex in general as artificial intelligence. You need to be thinking outside of the box, which is why we're doing these videos. And overall, I think this also is another key here for one of the mitigation strategies they have, which is that the plugins should be designed to minimize impacts. So of any of the insecure potential input parameters that may come about, the idea of minimizing the impact of any insecure input parameter, for any exploit is a really key thing here as well, again, for all three. And it does come back almost to science fiction here. You talk about RoboCop, for example. RoboCop was, designed to do very specific things, but it also had these parameters where it couldn't harm somebody. It was literally inputted into its programming. And I think that's the idea too, is that even if it somehow was to be exploited, there's some kind of overarching principled, maybe even ethical control data sets that will not allow, even if someone were to come in, to override those principles within that construct. Again, this is just talking generally. These are the ideas. How do you ensure that certain core responsibilities and ethics do not get bypassed? And making sure that any kind of exploitation of the system has its limits. This sandboxing, this minimizing the outputs that can happen from someone getting access to these systems. So now we're on to what I call the meat and potatoes of what I want to discuss today. So for large language model 8 here, the excessive agency is described as follows. An LLM-based system is often granted a degree of agency by its developer, the ability to interface with other systems and undertake actions in response to some kind of prompt. The excessive agency itself is the vulnerability that enables some kind of damaging actions to be performed in response to these unexpected or ambiguous outputs, regardless of what's causing this malfunction. They call it a hallucination or a confabulation, direct or indirect prompt injections, malicious plugins, poorly engineered benign prompts, or just a poorly performing model. The root cause of excessive agency is typically one or more of these things. So excessive functionality, excessive permissions, or excessive autonomy. And these are the ones I want to discuss today. What does it mean if this model has more capabilities than we intended? Or maybe it's given that excessive autonomy and we thought it was at a certain level and that was the right threshold, but it wasn't. What can these models do with this excessive autonomy and authorization and access? And how do we make sure that we safeguard our inadequacies in regards to if we made a mistake? And as human beings, we're going to make mistakes. There's obviously development environments where we can have the model there first, and that would be a part of a normal software development lifecycle approach. And that's for sure how it needs to be done. We'll have to make sure in these environments that simulate real life environments as much as possible. So not just, I think we have to think outside the box here. It can't just be a dev environment which doesn't have access or connection to anything and say that that's where we're testing it. We would have to actually have almost a simulated environment which has other networks that may not even be directly connected, but there's opportunity to connect to them, even internet type connections, to see what behaviors these large language models could potentially have, or other AI constructs, not necessarily even LLMs, to see if with excessive autonomy, maybe it does seek to find other information, it does try to get out. So I think we have to think about real simulation in regards to how we are testing these very powerful AI constructs. And that kind of testing will take more time, and it has to be obviously very, very methodical and detailed. And the better that we can create a repetitive and highly highly trusted methodology to this testing is also critical. I mean, we need to know, just like any kind of risk management process, that we are finding a consistent baseline, that we know through this testing that we're highly confident in it, and that we can get a consistent output from it, meaning that if we follow this program, there's a high likelihood of success and security by following it. Now, I know with the way that these models are progressing, that this will be an ongoing, like anything in security, evolving and ongoing continuous improvement endeavor, yet we do need to find some core principles and theory that we are confident with, that we feel that we can continue to inject into the development of these very powerful AI constructs. Giving just an example that can be obviously expanded upon to a very large level, excessive functionality. So the agent has access to a plugin that allows it to go from only being able to read something in a repository to being able to overwrite it. It's just a very simple concept, right? A little bit of extra permission. Excessive functionality in this case is extra permission. And it can modify and delete these documents as well. This obviously can be extrapolated into much more, deadly ththings, where it can go from not only, giving advice on, let's say, a life-saving solution, or if it's controlling something that is doing a task for us. It says, hey, you guys are dumb, you're humans, I'm the machine with access to all things. This is the output that we need to do, and I'm going to do it. So you've given me that autonomy, now I'm going to execute this without going to the human to say, well, wait a second, no, you can't, and we have some kind of bad outcome. So these are the kind of things that I am concerned about, because not being a data scientist, how do you allow the functionality to take place, but at the same time contain that functionality to the point where you know that it's staying in this specific true direction, and it's not easily able to be manipulated to do other things. So now, with some excessive permissions, again, the plugin that is designed to perform operations on behalf of a user, it accesses some other downstream system with a generic high privileged identity. So now you basically are allowing the system to act as a privileged user and to do things like yourself as the developer, as the data scientist. What happens in that scenario where now it's its own entity? It's no longer a programmer or even a hacker doing it, it's itself. And so massively powerful and quick that it can now do things to enhance itself, redesign itself, have other options that it didn't have before, and just, being simple, outthink the data scientists and the developers who first programmed it. Again, I know it's science fiction sounding again, but these are the out-of-the-box questions that I have, and I'm interested, like I say, to those that have more experience in this area as data scientists, oh, don't worry, this cannot happen because of ABC. That's amazing. I want to know more about this. I want to know more about how they think about this. I know from my own experience dealing with many developers who are very, very, very smart people, that usually when they develop a product, it's usually about the actual functionality first. They develop it to do certain things, and they work very hard to make a really cool product that helps the user experience and does the things that the users will want. And security may not be the first thing that these developers think about, because they've got to make things work first. They have a product to create. They've got functions that need to be sorted out, and they've got to make it smooth and slick, first and foremost. And security may not be, the first and foremost thing on their minds. I know these guys. I know these big AI companies. They have lots and lots of money. They're not, again, they're very smart people. They're hiring security professionals. That said, if the security professionals are looking at it from a more generic, exploit security level, these kind of different questions may get overlooked. So you need to, I think, as security professionals, yes, look at the application level security issues that we know about, the exploits we know, but we also need to be thinking outside the box and how the manipulation of these very powerful tools can be used. And for my final point here, when it comes to excessive autonomy, the plugin fails to independently verify and approve high impact actions. So in this case, again, more generic, but a plugin that allows the user's documents to be deleted performs deletions without any confirmation from the user. And this is what I was talking about before. When we have the excessive permissions or authorizations to modify something instead of just reading it, same thing comes down to the actions, right? So the LLM or other AI construct says, the very important thing happening here, I believe this is the right thing to do, and then it takes the action as opposed to confirming that action. And maybe it's a really bad action. Even though its intentions were good, it wasn't. Or to the contrary, where there's a poison data set and this data is bad and it's an unethical construct now, and now with those permissions and autonomy, it is now allowed to do things that it shouldn't be able to do. So in the end of the day, what do we do? The same advice is here for most of the other OWASP recommendations for this top 10 list, which is to limit plugins, limit functionality, avoid these open-ended functions where possible, which is what I'm talking about. You want to get all this cool functionality from it, this open-ended, that's what AI is in many ways. It's just an open-ended, capability to do things, think outside of the box for itself, or else you'll just have another normal application. But you do also need to limit some of those. There's some things you do not want it to do. And what are those? And how do you make sure that that is a part of the overall construct? Obviously, tracking the user authorizations. This is a really key one, I think, as well. The security scope to ensure actions that are taken on behalf of a user user are executed on downstream systems in the context of that specific user and with the minimum privileges necessary. The idea that, for example, here it says the plugin reads a user's code repo should require the user to authenticate, in this case via OAuth, with the minimum scope required. So making sure that what is being requested is actually happening and that there is this interaction and authorization and authentication, between not just the system itself, but with the user itself. So there's some kind of oversight. And we're going to get to oversight in a second, because oversight is obviously a massive thing when it comes to AI systems and their overall constructs. I'm going to just finish on this with the actual scenario. Again, it's funny, up until this point, there was like multiple scenarios for each. This one they just put into one paragraph, which I thought was interesting. So the AI construct personal assistant app is granted access to an individual's mailbox via a plugin in order to summarize the content of incoming emails. To achieve this functionality, the email plugin requires the ability to read messages. So very similar to what we talked about before, it had read access. However, the plugin that the system developer has chosen also contains functions for sending messages. The AI construct is vulnerable now to different types of indirect prompt injection attacks, whereby a maliciously crafted incoming email tricks this model into commanding the email plugin to call the send message function to send spam to a user's mailbox. So just again, a simple idea of manipulating the base functionality. This could be avoided by eliminating excessive functionality by using a plugin that only offered mail reading capabilities. We already talked about the fact that sometimes with excessive permissions or autonomy, it could find this on its own anyways. And B, eliminating excessive permissions by authenticating to the user's email service via an OAuth session with read-only scope. So now we're dealing with some of these excessive permissions, which is good. And then C, eliminating excessive autonomy by requiring the user to manually review and hit send on every mail drafted by the AI plugin. So again, comes back to the point of, I'm not saying this is not a solution. It is, and we may in fact need to go with some very critical decision-making points within the AI functionality and definitely have these manual interventions. A manual person saying yes or no to certain functionality. That said, from a tenable ongoing solution, that's going to be a bottleneck, to say the least, when it comes to overall functionality. Now, again, some will say, and I agree, that on certain very key critical decisions that are national security, people's health, key systems that we depend upon, water systems, electrical systems, we would need that if AI is introduced there. Military systems, obviously, and I'm all for that. That said, is there ways that we can still get confidence from programming the data sets, the actual AI constructs themselves, that they can self-monitor, and there are these systems that cannot be tampered with, that we know there's these principles and theories that the system runs by that cannot be changed, no matter what kind of bad data comes in, and no matter how much power that AI construct has, it cannot change these core, for lack of a better word, ethics. It's just something to think about. So finally, we come to the LLM 09, over-reliance. So we already are seeing this with deepfakes, fake news, and again, I talked about this earlier with the GAN models that are able to basically help to both create deepfake or fake data and to detect it. So it continues to help each other to create better and better deepfake data. We have a situation now where we're going to be using AI more and more, and we're relying on it more and more. And a part of that would be things like information-based attacks, where we think we're getting good information, but it's bad information. So, I'm going to go straight to the attack scenarios. A news organization heavily uses an LLM to generate news articles, and a malicious attacker exploits this over-reliance by feeding bad information and misleading information, and therefore causes a spread of disinformation. Again, a very simple scenario, but this is back to we want to utilize these systems. They can do things better than human beings can, and we want to improve our society based on this technology. That said, this is highlighting the earlier points, which is we want to make sure that the information we're getting, the constructs themselves, are functioning in such a way that we can depend on them. We have confidence in their output and that they're not easily manipulated or poisoned. And we want to make sure that, especially when it comes to decision making based on this information, that we know good decisions are being made by these AI systems if we get to that level. And I'm sure we will at one point, where certain decisions that are beyond the speed of human capability are needed in certain situations. And we got to be very confident in whatever those outputs are going to be. I'm just going to read here from the description. Over-reliance can occur when the AI model has erroneous information and provides it in an authoritative manner. And these LLMs can produce creative and informative content, but they can also generate content that is factually incorrect, inappropriate, or unsafe. This leads us to, I think, probably the biggest thing when it comes to what we do. Like, we talk about controls and security controls and technical controls. Again, all very, very important, but they have to be under the umbrella of this overarching governance framework for oversight. And no one likes oversight. I've talked about it in earlier videos, how we don't want to be security impeding the creative design of these AI constructs and get in the way of developers and data scientists who are doing great work. That said, this collaboration is critical in my opinion. We're trying to reach the end state of these AI constructs and get all the functionality that we can and the power that we can out of these AI constructs. At the same time, by injecting security, controls, methodology, oversight as far left as possible, allows a greater confidence in the output as early as possible. Because if you inject the security later on in the process, you may have missed certain states of that build where security was appropriate to be injected. And I think that's the idea too, is laying out the entire we use for quote normal security, this data flow to understand where to inject security controls. In a very similar way, we need to be able to understand the full large language model and or AI construct from end to end and how it does its thinking, for lack of a better word, and to know where security needs to be injected and parameters and controls need to be inputted so that they're in the appropriate places as well. So you don't just want to say security, 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 but it doesn't have the actual output that you are hoping for. You want it to have a purpose. So again, security can't just be blind and saying, let's just put this idea of security everywhere, not knowing what its output is, the intention, what is it that you're trying to achieve, what is the success criteria of each and every control that you put in place is needed as well. So we want to make sure that we're doing, and we're actually applying security in the proper way. I've seen before with certain models, things like DAGs, where people are using SDLC type thinking and security methodologies for them, where they may not be as appropriate because it's not the same kind of technology. It's not a secure development lifecycle exactly the same as a normal application development path. So you have to think outside the box. You have to think specifically for how the AI technology is being utilized and how data scientists are training these models and how the data is used, the math behind these models, what is being done, and understand how security can be injected in these places. So you're going to need data scientists with a security hat to really help to be a bridge to us as security professionals. And as security professionals, it's on us to learn about AI, how it works, the core fundamentals, principle, and theory of AI technology, so that we can give informed information back. And this is something I'm working on now, and I will continue to work on, because I know that I need to become as educated and as informed on this topic as possible. And it's a massive topic. I think with all these ideas combined together, and thinking about, again, not just the normal exploits, the application security vulnerabilities that we see day in and day out, looking at these more AI-specific challenges and threats and exploits, how AI itself can be manipulated. An attacker now having more intelligent AI system working with them to help actually bypass, security controls and put into place is extremely powerful versus just thinking about someone exploiting a system and having more access now from that exploit. We have to think differently. We have to think about what happens if, these systems are getting wrong information or bad information, poisoned information, bad data sets. We got to think about how to create this shifted left security validation from as early as possible in its development all the way through until final implementation to production and or into the wild. And how do we maintain control even when these AI constructs are in the wild or are in a situation where our lives are at stake? What are the parameters we can use to make sure there's always some kind of control for us as the creators of this AI technology? So I think there's just so many different questions about how AI can be utilized for good and as well how AI can be utilized for ill. And together as a community, I hope that this video and these videos and the other videos that we've discussed on AI technology will create more discussion. And together, again, we have some very smart people in this community that we can utilize and harness all of our background, all of our experience from these different groups in these different areas to create effective approaches to secure AI technology for the present and into the future. And SecureX definitely will be that group that will help to lead the way as much as we can. And we welcome again all of your feedback. So thank you so much for listening to this today.